Hello guys, welcome to this new video. In today's video I will be discussing the technical details of the latest AMD Ryzen Threadripper PRO 5000 series, 5000WX series. You guys might be aware that a few days ago I you know created another video where I discussed a little bit about the AMD Threadripper Pro series processors. In that video, I was basically going through why we need that Threadripper Pro processors, what are the potential use case of those Threadripper processors, right? How they are different from the normal Ryzen series of desktop processors, right? So if you guys haven't watched that video, I recommend you go and watch that video. I'll give the video link in the description. Okay, now let's go into this new video. Here as you can see, we have the model specifications for these the Threadripper Pro 5000 series of processors. All these processors are targeted for the for the workstation class workload. So if you can see, the lowest you know uh, performance model is 5945WX. Then we have 5955WX, 5965, 5975, and 5995. So the top model is 5995WX. So if you look at the 5945WX processor, has 12 physical cores, and and each of these cores have 2 threads. So in total, for 12 physical cores we have 24 threads. Similarly, for 16 cores, 32 threads, and like this, for the top model you will get 128 threads for 64 physical cores. Okay, and if you look at, we have the highest frequency here. If I talk about the base frequency, this 5945WX processor has the highest frequency, that is 4.1 gigahertz. That is the base clock. That means you will get minimum 4.1 gigahertz frequency in this processor. So that is a good thing if you are going to play a lot of video games, where you need high frame rate. So in that case, this kind of high frequency processor will definitely help. And as you go up in this list, the base clock frequency is getting reduced. If you can see, the 5955WX processor has 4.0, then we have 3.8 for 5965, then 3.6 for 5975, and 2.7 gigahertz for 5995 WX. And the TDP means total power consumption, you can say, in simple words. It is 280 watt for all these processors. That is same. So now it is really important to understand how to choose the best processor for you. So like I said, if you know what are the applications that you are going to run in your workstation system, then it will be a little bit easier for you to choose the right processor, right? For example, if you know that you will be mostly running applications which require a single core performance, then you should go for this 5945WX series of processor. Here you can see the core count is less, it is only 12. In total you will get 24 threads. If you believe your workload will not need more than 24 threads, then you can settle for this one, 5945WX, right? On top of that, you will get the highest base clock frequency here, 4.1. That is good enough for you. And if you believe 24 threads is not good enough for your workload, then you can definitely go up and try this one, the 5955WX with 32 cores, right? But if you, without thinking about your workload, if you simply go for this one, the top model, where you will get 128 threads in total, on the other hand, if your workload doesn't need 128 threads or 64 physical cores, then all the other cores or the threads will be like simply sitting there doing nothing. So there is a lot of computing resources getting wasted for you. So if that is the case for you, you know, you understand your workload quite well, then you should not go for 5995WX. And you know, but in some cases, for example, if you use any video editor, let's say DaVinci Resolve, which uses a lot of processor cores. In that case, you should go for 5995WX, because I know I use the Vinci Resolve video editor, and that's why I know this video editor needs a lot of processor cores. I mean, it can work on processor with low core count as well, but if you give this video editor a lot more processors, then it can do the job. It can complete the rendering at a very less time. It is good if you feed more processing cores to the Vinci Resolve. It likes it. It will do the job in a very quick time for you. So if that is the kind of workload you are going to have, which needs a lot of processor cores, then go for this 5995WX. We need to understand that it is not as simple as it is sounding right now, because of course, like, you won't be only running on one single application which needs this many cores, right? You might be doing a lot of stuffs there, which may not need this many cores. In that case, you need to find a sweet spot for you which works well for you. That's what I'll be telling you. And if you look at this 5995WX processor, this processor will have the highest multi-core performance, right? But the single core performance will not be greater than this 5975, 5965, and 5955, 5945, right? So if you talk about the single core performance, then 5945WX will be having the highest single core performance, right? So as I said, if you are a gamer, where you need the highest frame rate possible, then you should go with this one, because you will get highest base clock frequency. And probably, and if you also know that the game you are playing, it doesn't need that many cores, then this is a win-win situation for you. You can happily go for this 5945 processor, right? But this is just an example. But for gaming, probably this is not the best processor available in the market. Probably you can go for Intel's latest i9 processors, or you can go for other AMD Ryzen series of latest processor. Ryzen 7, I think. There you will see the clock frequency is higher than this, and it can go up to, I think, 5 gigahertz plus. So there you will get more performance. But this explanation is only to show you how to choose the best Threadripper Pro processor for you. Search for CPU benchmark, then you will see this website. This is just one random website I'm picking. I go visit this website and take a look at the list from time to time. But you can take any other benchmarking tool to get this kind of information. So in the CPU section, you can go to a high-end section there, and here all the processors are listed. And on top of the list, here you go, you can see the top performing processor is AMD Ryzen Threadripper PRO 5995WX. This is this guy, the top one. Okay, this is having the highest performance score, that is having 108822, and that is even having higher performance score than AMD EPYC 7763. This is a server class processor, so it is even beating EPYC series of processors. That is a really stunning thing. So if I click here and try to look at the details of this performance benchmark, there you will see it is listing out all the clock speed and the turbo speed, thread scores, and everything. But if you go down, you will see there are some parameters listed here, performance parameter. So from here we can see that if we talk about integer math, it can perform 650 million operations per second. And if you talk about floating point math, it can perform 354 million operations per second, right? That is huge. And so similarly, you can see different numbers for data encryption, data compression, and physics, random string sorting, find prime numbers, and all those things, right? So you can look at these numbers in detail, and you can compare all the processor, and then it will be easier for you. Like for example, if you're a scientist, or if you are if you are a student doing some complex physics simulation work or anything, then probably you can take a look at this particular number, and you can compare with compare different 5000 series processor, 5995, 5975, and like that. You can compare these numbers, and it will give some valuable input to you, so that you can choose the best Threadripper processor for your workload. And this is the one I'm talking about. So if this is the single thread performance benchmark number, so that means in single thread it can perform 3000 million operations per second. Okay, this is what we have: 3000 million operations per second. That is for this guy, the top model 5995WX, right? Now in this list, if you go down a little bit, you can find this one, 5975. Let's click here. So 5975, this is this guy, the second guy. Okay, and this processor has all the performance details. Again, you can see, you can go through all of this and take a look at this number, single thread performance. This benchmark number is still 3000 million operations per second, but to be precise, it is 3340, but this guy had 3330. So at least there is a difference of 10. So you can see the single thread performance is better in this 5975WX, and this has less core count, right? And let's go back to that particular list and try to find out the base, the lowest model here, 5945WX. Let's go find that processor in this list. So that will be definitely somewhere down in the list. This is the one we are talking about. So this is 5945WX, right? If we click here, we will get the similar list, and here you can see single thread performance is 3343. So this will be having the highest single thread performance, 3343 it is having, and 5995, this one, and this one is having 3330. Okay, so that is how you can see that if you really care about single thread performance, then go for this one. Actually, 5945, it is having the lowest core count, but you will get the maximum single thread performance. So I hope this is making things a little bit easier for you to choose. And okay, after that, after going through all this core count, thread count, and processor clock frequency, another important thing to note here is the L3 cache. So L3 cache is another parameter that we need to look at if we want to evaluate the performance of any processor, right? So if you have more L3 cache, then it can give you some performance boost, right? So how L3 cache is playing a role here, I will try to explain very briefly. There are a lot of YouTube videos, you can go through all of those if you want to know in detail, but in simple words, how a processor works is, so the processor basically performs any tasks using some instructions. Okay, it uses those instructions on the data which it receives from different input devices. So for example, if I want to calculate something, let's say 4 plus 5 equal to what, if I want to perform this particular operation, then whatever we enter, let's say we entered 4, then we entered plus, then we entered 5, all these inputs will be stored in the memory temporarily. For example, it will be stored in your RAM, 4 plus and 5. Okay, then this 4 will be sent to the core, plus sign will be sent to the core, and 5 will be sent to the core. Okay, from the RAM it will travel to the core, and then the core will read 4 5, and it will read the plus operation, and it will understand that okay, I need to produce the sum total of 4 plus 5, and it will do all the calculation, and it will give the result as 9, and it will be finally displayed to you. So now you know the 4 will have to travel from the memory to the core, then plus 5 has to travel to the core from the memory. So basically there has to be some kind of data travel from the memory to the core. Okay, and this data travel takes time. Normally, you know that data traveling time is very less. It will be in nanosecond or picosecond in today's standards, right? For a single operation it is fine, but in some complex operations, what happens is, if you want to pull a lot of data from the memory, then what happens is a lot of time gets wasted in simple data transmission from the memory to the core, again from the core to the memory, like that. So that is why we need L3 cache. So L3 cache is, you can say in simple words, another type of memory, but these memories normally reside very near to the processor core. So what happens is, in modern processors, they have some intelligent technique where the processor can prefetch some of the data which it thinks it will need in the next iteration, right? For example, you are running one particular program where you have a for loop. Let's say in the for loop you are running the for loop for 100 times, and each time it is simply adding two numbers, right? So in that case the processor will understand, after I think couple of iterations, the processor will understand that okay, I need to repeatedly add two numbers, right? In that case what it can do is it can simply store that plus operation in that cache memory, L3 cache memory near the core itself. That way the processor doesn't have to go to the memory and bring the plus operation, plus operator every time. It will simply store the plus operation in that L3 cache memory itself. Only thing it needs to find fetch is the input data, 4 5 6 7, whatever it is. So that way intelligently the processor can store the important instructions or data which it thinks will be used frequently during the operation. So that way that data traveling time will be reduced, because L3 cache will sit very near to the processor cores, so data traveling time will be very less, your overall performance will be very fast. And that is why we need L3 cache. And if you have more L3 cache, that means you can store more instructions or more frequently used data, and that will definitely speed up the overall performance of your processor. Okay, this is the very simplest explanation, but if you go into the technical details you will see that things are much more complex. In one theory or in one formula we cannot for certain we cannot for sure say that this will be applicable for all types of workload or anything like that. We cannot say that, but at least this is a fact that if you have more L3 cache in your processor core, it is definitely better. It will definitely help you get more performance out of your processor, right? So that is why it is important to look at this L3 cache number. And let's look at what is the L3 cache number we have for this particular processor, for this 5995WX processor. If you see, the L3 cache is 256 MB. Okay, and similarly for 5975WX, the L3 cache number is 128 MB. Okay, similarly if you go to the lowest model here, 5945WX, here L3 cache number is 64 MB, right? So this processor is having the lowest value of L3 cache. So looks like this processor will have weak performance because it has the least amount of L3 cache, right? And but you need to understand, in all types of workloads L3 cache number may not give you the desired performance. So for example, if you are playing a game where all the actions are happening quite randomly, the actions are not repeatable, right? If you are moving into different terrain, you are facing different scenarios, or if you are facing very random situations for the first time, probably in those scenarios the processor won't be able to reuse some of the already stored instructions, right? In that case, L3 cache memory may not help you. But for example, in some other cases, let's say you are a programmer and you execute a lot of Python program. So in Python codes, normally what happens is uh, the branch prediction algorithm comes into play here, because in Python programming, some of the instructions can be repeatable, and that is why the processor likes to store those repeatedly used instructions in the L3 cache memory, and that way it can easily pick up those instructions for the L3 cache which is sitting nearby, and the data travel time will be reduced and your Python program execution will be a little bit faster. So this is just an example. So you need to understand understand your workload quite well to get the benefit out of your L3 cache, right? So probably in this case, if you are a Python programmer, then the more L3 cache you have, it is the better it is for you. um, this is just the explanation behind this L3 cache. And so you have seen this 5945WX, this processor has the least amount of L3 cache, and 5995WX, which has the highest number of L3 cache. And now I will try to write down the L3 cache number for each of these processors, and then we can try to understand which one to go for. Okay, so you can see I have written down all the L3 cache details of this processor. So if you look at this particular processor 5995WX, it has in total 128 threads, right? And as I told you, it has 256 MB in total. So 256 MB L3 cache will be shared by these 128 threads, right? So that is what 256 MB divided by 128 and so on average each of these thread will get 2 MB L3 cache. So similarly for this second one, it has 64 threads in total, and this processor has 128 MB L3 cache in total. So 128 will be divided by 64, and on an average each thread will get again 2 MB L3 cache. But if you look at this 5965WX processor, where we have 48 threads in total, but this processor in total again has 128 MB L3 cache in total. So that 128 MB will be divided by now only 48 threads. So individually each thread will get 2.6 MB. That is that is really good. So each of the threads will get 2.6 MB, but on those two previous top processors, each thread will only get 2 MB, but now here you are getting 2.6. So that is a good thing. And again, if you look at this 5955WX processor, here you have 64 MB L3 cache in total, and you have 32 threads. So again, each thread will get only 2 MB. And in case of this last one, 5945, again 64 MB divided by 24 threads, you will get 2.6 MB memory for each of these threads. So this is a little bit of analysis to understand which one is better for you in terms of L3 cache. So for example, if you know that your workload will not need let's say more than 48 threads, if you are sure that you will need only till 48 threads in total, You will not need more than that. In that case, you can go for this one, a 5965 or 5945, because in 5965 you are getting 2.6 MB L3 cache for one single thread, and the same case here also for 5945 you are going to get 2.6 MB for one particular thread, right? You are getting more L3 cache for your single thread, right? um, in that case you can choose any one of them. Now since this 5965 and 5945 both are giving you 2.6 and 2.6 MB L3 cache for one or each of your threads. Now the deciding factor will be uh, you know um, up to you. Like if your workload demands more than 24 threads, then go for this one because it has 48 threads. But if you think like your 24 threads are good enough for you, then you can go for this one. You will get this processor at a lesser price as well, right? um, so that is the thing. And on the other hand, if you also know that your workload doesn't need a high base clock frequency, then you can go for this one again, because here it is like 3.8 gigahertz. But if you need your base clock to be higher, then you can go for this one, right? And that is what it is. And this L3 cache per core, or per thread rather, is very important parameter, right? So that is why these two processors are giving you the highest L3 cache per thread. If you believe this is an important parameter for your evaluation of workload, then I think these two can be good choices. Right now, of course, this one has the lowest price, and this one will have a little bit higher price, but this one has the highest price. Okay, and you don't have to go to this top model if you don't need this many cores. Okay, so this is briefly what I was going to tell you guys, and hopefully uh, you know uh, this will help you guys to understand better in terms of what processor to choose from, if you are not familiar with this kind of concepts. So I understand that this video is quite poorly produced and poorly edited, but I'm just getting started. I work in this field. I know the technical details a little bit, but for a normal audience, I'm trying to explain in simple words. To those of you who are already working in this field and know the technical details in depth, then probably this will not help you that much because you already know it. But if you are new to all these things and you are not familiar with this kind of performance parameters, then I believe this video is going to help you a little bit. Okay, so this is what I had for today. I hope to see you in my next video. Thanks for watching.